skeletal structure is a simple model of organic compounds. And we leave out the hydrogens. We don't show hydrogens. And then our structure is showing the carbons, but we also don't draw the carbon. We don't write C. So what we're going to do is we're going to assume anytime there's a corner or a junction. So we could have two lines crossing, where those lines cross with the carbon. So a junction is a carbon. And then we just have to remember carbon likes to form 4 bonds. So anything that's not shown to fill our 4 bonds for carbon is going to be a hydrogen. So then once you draw your skeletal structure, you're going to draw all heteroatoms. So remember, a heteroatom is like oxygen or nitrogen or a fluorine or chlorine. Those are heteroatoms. So we do draw those. And if it's like oxygen, we draw all the hydrogens attached to oxygen, all of the hydrogens attached to nitrogen. We just don't draw any hydrogens attached to carbon. So this is our rule for skeletal structures. So while you're taking notes, Alex will ask you specifically, it will say, draw the skeletal structure. That's what we're talking about today. Or it will say, draw the condensed structure. So if it says condensed structure, you better not draw the skeletal structure. A few people last year didn't read what it wanted on the test, and they drew the wrong structure. And so I can't give you points back if you're drawing the wrong structure. Okay? So skeletal structure is also called the line structure. So just pay attention to the question. Is it asking you for the condensed structure or the line structure? Okay, so here's an example. On the left, we have just the whole Lewis structure of cyclohexane. On the right, we have the skeletal structure. So we have these corners. So notice we have every corner is carbon, and then we don't show any hydrogens. So we just have to look at this carbon and know, well, this carbon is bonded to 1 carbon, 2 carbons, and carbon wants 4 bonds, so those 2 missing bonds must be hydrogen. So you just have to recognize that. So that's our cyclohexane, and that's our skeletal structure of cyclohexane. This is an example with a heteroatom. So we have cyclopentanol. Notice we have our corners are all carbons. This corner, we have, it's bonded to oxygen. We do draw the hydrogen on the oxygen, but we don't draw the lone pairs. Okay. The other thing that you need to recognize is that this carbon here, there's a corner, so that's a carbon. This carbon has a bond to oxygen, it has a bond to a carbon, it has another bond to a carbon. Carbon has to have 4 bonds, so the hidden bond, the invisible bond, is a hydrogen. Okay? So that's something that you're going to have to recognize. Does that kind of make sense? Okay. So, and that's also, you can see it looks like it's just a line drawing, that's what we call it. Skeletal structure or the line structure. Okay, so what's happening in a linear carbon is the end is a carbon, this is a carbon, this is a carbon. So the ends are carbons and the corners are carbons. And then you have to be able to recognize this carbon has 1 bond to another carbon. So it has 3 hydrogens to complete its 4 bonds. Okay. Do you remember what a CH3 group is? Okay. Yep. Now I can't remember what it is. Methyl. There we go. Methyl. Methyl group. Methane is CH4. Yep. Methyl. So methyl group. Good. Okay. Remember, if we have carbon, carbon has 4 electron groups. What is the bond angle? Yeah, 109.5. So any of these have 4. So every carbon, it has 4 groups. It's going to be tetrahedral. And so what's really happening is carbon is not a linear molecule. Or if you have a carbon chain, it's not linear. You have these, it's kind of like a step, like a ladder. If you tip this on its side, it would look like a ladder. That's what actually is happening. So that's why we draw it like, in our skeletal structure, that's why we draw it as a zigzag. Because that's what is actually happening. Okay. All right, so Alex is going to make you draw a few skeletal structures, and it's really picky. So here are some tips. As much as you can, you want to make it look like the structure they give you. So this is pointing up. I'm going to try to make that pointing up. And then the other thing you can do is you can count these carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so that can help you figure out where your carbons need to go. The other thing that you need to do is that this needs to be an obtuse angle. So on the test, it's going to mark it wrong, or in your Alex homework, it's going to mark it wrong if you do something like this. Because this is technically right, you still have 1, 2, 3 carbons, but this is like really like a messy handwriting. So you need to make sure that what Alex wants is that this needs to be obtuse a little bit. This is a 30-degree angle. What you're trying to go for is, if you drew all of the, that doesn't look very clear. If you draw all of the bonds in something, you could, like, if you continued to draw this, you'd end up with a hexagon. Okay, so just imagine drawing your skeletal structure along part of the hexagon. You can actually buy notebooks that have graph paper, and instead of like the boxes, squares, it has hexagons to help you draw organic molecules. So that's kind of interesting. So that's really important. This is something that people run into. So if you draw the correct structure in Alex on the test, I can go back and give you partial points. But on the homework, you guys have to get through the homework. So you need to figure out how Alex wants you to draw it correctly in the homework. So that's some tips. Okay, when you're drawing substituents, so I have my main chain, and then I have a branch. The branch is going to go with the point. So if there's a branch here, I'm not going to draw it down. That would be incorrect. I'm going to draw it the direction. This is kind of like an arrow. It's going to point up. This one is pointing down, so my substituent is going to go down. Does that make sense? Okay. This is kind of like just like keeping track of our rules. And then if we have two, so we have this carbon that has 2 different groups, we're going to put them pointing up, but there's going to be a 60-degree angle in between them. So it's like we put one up, and then if we have 2, then we split them by 60. Okay, so this, the more that you see this, the more you'll get used to this. It's not too bad. Okay, questions? You're okay? Okay, the last thing that we need to talk about before, so we have, this is like our last drawing skeletal structures, and then we'll get one more. So if we have a double bond, we have to draw the substituents on the same side of the double bond. So if we have a single bond, our molecule can rotate around that single bond like this. Like if we had a bond, it will rotate. But if we have a double bond, this locks the bond in place. So across the double bond, these 2 have to be on the same side of the molecule. So what I'm meaning is if I cut the double bond in half, this is the top and this is the bottom. So if I come over to my skeletal structure and I cut my molecule in half across the double bond, this is the top, this is the bottom. So these substituents have to be on the same side. That double bond locks the molecule and it can't rotate around a double bond. So this is a completely different molecule than this. They will have different properties, they'll have different melting points. So these are different molecules. So can you see how these are on the opposite side? This one's on the top, this one's on the bottom. You see that? So you have to draw whatever Alex gives you. If it's on the same side, you're going to draw the substituents, the groups on the same side. If they're on opposite sides, you have to draw them across the double bond. They're different molecules. Okay, so go ahead and try to draw the line structure for these.
It's going to be very small.
So there's one on each.
Alright, well, I don't know how to do this. I was paying attention.
So throw something down. Try it out. This is like you have to practice it for it.
Well, hold on. I think I am. I'm just going to So we drew a line in that direction, and then there's another one that comes like this.
You write up H2N.
So I think it'd be like.
Yes.
Oh,
Yes.
I had
Because
no idea where to put it.
yep, you write all out because it's a hydra. Otherwise, we'll think it's a carbon.
How do I know it's a hydro atom?
Because it's not carbon. Okay.
Carbon's there, and then so.
Uh-huh.
The other one is the receipts.
Yep. Yep.
Hold up. We don't cook it in the studio. And then. Okay, I think that's the first one. Second one, I think is like. Line. Okay, then. Oh, so we're, this is the one. Oh, like that maybe.
How was yours going?
On the singers. Compare to our first one.
It's close enough.
Wait, it's supposed to be like that. Here, I'll redraw.
That's fine.
It's like Are you doing the second one? Yeah. You just hate me. Yeah, I know you do. If I land this one, what if I said no? So what is it? Oh, wait. I know what I'm doing.
Okay, another few seconds, and then we'll talk about it.
I'm not going to. Yeah, I don't care. I don't. It's just kind of
Okay, let's go over it. So,
Wait, hold on.
oops. I like to label the carbons with numbers. So 1, 2, 3, 4. We have 4 carbons on our main chain, and we have a nitrogen. So I'm just going to put this nitrogen. The other thing is, if I start going like this, and you start going like from down to up, that's fine. That's still the same molecule. If you can flip your molecule, even if you draw it like this over here, if you like mirror your molecule, that's okay too. Okay, I think it's easier if you just stick with like left to right, but there's lots of correct ways. So I'm going to start here. So I'm going to draw my nitrogen. So I have to draw the nitrogen. I have to draw the hydrogens on the nitrogen. And then I have 1 carbon. Let's see, 1, 2, 3, 4. 1, 2, 3, 4. And then I need to get rid of my other piece here. Okay, so then at carbon 1, we have 2 groups. So we're going to put, perfect, thanks.
Oh,
Oh,
I have a question.
yeah,
What's
2
up?
carbons here.
What time is lunch today? Because it's early out today, right?
I don't know. I have it on that sign over there.
Do anybody know when it's lunch today?
Yeah,
What time is lunch?
Like 8:50.
10:40. I think it's
10:40?
done. After notes, we'll check after notes. Okay, so we have our two methyl groups, CH3 groups off the top. Okay, and then we have this group. So we can't make it go up. This is pointing down, so we're going to put off of this second carbon, we're going to put this group. And you could put that this way, you could put it that way too, because the bond can rotate. So this could go down and right or left. I just decided to go that way. Okay, so something like that. Questions on the first one? Okay, so the second one, I'm going to number my carbons. You can do this in your head, it just helps me to write it out. So then we have our double bond. Are these on the same side or opposite sides? They're on, one's on the top, one's on the bottom of the double bond. So we'll have to think about that in a minute. So I'm going to draw my 5 carbons. 1, 2, 3, 4, 5. If you follow, so if it's odd, they'll both point the same way. If it's an even number, they're going to point, one's going to point up, the other one's going to point down. That's a pattern you can watch for. Let's see, so I have my 1, 2, 3, 4, 5 carbons. So our double bond is from carbon 3 to carbon 4, that's my double bond. And then at carbon 4, we need an OH group that points up. So that's kind of, and then we need a methyl group at carbon 3 that points down. So they're opposite sides. Yes?
So does it matter where you put the line for the second bond? Like whether it's. Yeah, above, I put it below.
You put it below?
Yeah.
Yeah,
Can you do that too?
Yeah.
Okay.
That's fine. Yeah, like that. Yeah, that's fine. Yep. No, that doesn't matter. Okay, so this is something like, obviously, Alex is not checking this. So we care that we get through the assignment. So make sure you practice this in Alex. Make sure you understand what Alex is expecting you to do. Okay, the last thing that we're going to talk about today, and the last part of chapter 11, is identifying where the hydrogens are. So on a skeletal structure, even though they're not shown, you need to know where they are. And so it's going to have you switch between hydrogens and chlorines. So what I use is the 4-carbon bond rule. I look at my carbon, and then I count how many bonds, and then everything else is a hydrogen. Okay. So let's go ahead and look at these molecules. So if I have this molecule, and I have a carbon here. Oops, that's an eraser. There's a carbon here. How many hydrogens are attached to that carbon? This one?
No,
1. So this carbon has 1 bond, 2 bonds, 3 bonds. It has 2 to the other carbon. So that 4th bond is a hydrogen. So if we were drawing in the hydrogens, it would be here. Okay, this one. How about this one? 1. So we have 1, 2, 3 bonds. The 4th one is that invisible hydrogen. Okay, how about this one? Also 1. 1, 2, 3 bonds. The 4th one is our hydrogen. How about this one? Also 1. We have chlorine, 2 carbon bonds. The other one's hydrogen. Okay. This was one of the most missed questions on the test last year. So it seems simple, but make sure that you're practicing. Alex makes you switch between hydrogens and chlorines. So once you know where the hydrogens are, you have to either draw chlorines in, or you have to switch chlorines and draw the hydrogens. So just make sure that you practice that topic. Make sure you understand it. It seems straightforward, but a lot of people missed it last year. Okay, let's go here. We have a carbon here. How many hydrogens will be there? Just 1, good. How about here? Also just 1. Okay. Okay, let's go over to, so an end is a carbon. How many hydrogens? 3, good. So to fill in our octet, carbon has to have 4 bonds. So 3 are from hydrogen, 1 is from that carbon-carbon bond. Okay, how about this one? Good, just one. We have 3 bonds. The 4th one is carbon, or hydrogen, excuse me. How about this one? Good. So we have carbon, 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 carbon. The other 2 are hydrogens. And how about this one right here? Good. So there's 3 bonds. The 4th one is hydrogen. And then this molecule is mirrored. So there's 3 here, 1 here, 2 here, 1 here. Okay. All right. So for the questions that ask you to switch between chlorines and hydrogens, I would draw it out, figure out where the hydrogens are, or switch it to hydrogen, and then redraw the skeletal structure. Okay, that's all for notes. You have chapter 11, Alex. You have lab 13 if you haven't done that. You can do corrections. If you turned in before today, I have graded your lab, so you can do corrections for lab 13. You can do pre-lab for lab 5, which is on Friday. We have a signature assignment. You can practice for your final. So lots of things to work on.